with a DBT committee.
Okay, good morning all of you, all the participants. Department of Electronics, Sri Shivaji Mahavidyalaya, Barshi. We are organizing a guest lecture series. This guest lecture series is co-sponsored by the DBT Star College Status Scheme, which we received in the 2021. Okay, so under that scheme, we are organizing these guest lectures. Totally, we will be having 6 guest lectures, and the first guest lecture we are starting today, and the resource person is Dr. V.S. Shirwal, who is the faculty from N.K. Orchid College of Engineering and Technology, and he is heading the Department of Electronics and Technology. So today is our first guest lecture, and the topic of his lecture is wireless technology. Okay, so you know that whatever mobile devices and many other devices we are using, they are falling under the category of wireless technology. And wireless technology is the you can say booming very fast in the world. You must have seen that landline phones and which we were using 10 years back, 15 years back, they're getting outdated and they are getting replaced by the wireless technology, today's wireless technology. Okay, and not only that, we also see that with the advent of the technology, the speed needs to be increased. Okay, not only wireless is sufficient for us, we need to increase the speed of the device also. And that's why we have seen that there are versions, different versions of the mobile, that is 1G, 2G, 3G, 4G, and the latest one which is going to come or arrive in the country, that is a 5G technology, okay, which will be launched very shortly in India. So we have to keep up ourselves with the pace of the technology, and that's why we have a very nice lecture person who is a head of the Department of Electronics and Technology, Dr. V.S. Shirwal. I welcome him for the first guest lecture. Okay, and he will be giving you all the basics of wireless technology as well as whatever advances are going on in this technology in the today's world. That also he will be discussing. Okay. Because the audience is very varying. As we know, the audience composes of BSc 1 student or even 12th standard electronics student up to the MSc level. Okay, so keeping in view of this audience, we have organized this lecture series, and we have requested all the authors or all the resource persons that please consider the basics also, and then go to the advanced features which are coming into the picture. I welcome Dr. Shirwal sir first lecture. Okay, I also welcome all the participants who have taken keen interest, who have devoted their time in joining this lecture seminar. Okay, I switch over to Dr. Ghodke, who is the head of the department of our electronics department, and he will be introducing our today's guest. Okay, over to Dr. Ghodke sir, please.
Good morning to all. On behalf of Electronics Department, Sri Shivaji Mahavidyalaya, Barshi, it gives us an immense pleasure to welcome today's resource person, Dr. Vijay Kumar Shirwal from N.K. Orchid College of Engineering and Technology, Solapur. Respected principal of our college, Dr. Bharti Rewardkar Madam, my colleagues, Dr. Gurme sir, who is the DBT coordinator of our college, then T.N. Lokhande, the science coordinator of our college, then S.S. Suryanshi, professor from School of Physical Sciences, Solapur, and my colleagues, Dr. K.P. Deshmukh, Electronics Department, DBT Coordinator of this online guest lecture series. Dear participants and students, first of all, I am thankful to Dr. Vijay Kumar Sirwal accepted our invitation to deliver first guest lecture on wireless technology in spite of his busy schedule. Because the wireless communication plays a very important role in the commercial. Wireless gives convenience to all people that use technology. Wireless communication revolution has brought fundamental changes to data networking, telecommunication, and has made integrated network as a reality. So wireless technology is an excellent track of future in industries. So today, I am now introducing about chief guest, Dr. Vijay Kumar Sirwal, sir. Dr. Vijay Kumar Sirwal, sir, currently working as a head of electrical engineering and associate professor in the Department of Electronics and Telecommunication, N.K. Orchid College of Engineering and Technology, Solapur. He is a BE in Electronics, MTech in Electronics and Telecommunication, and PhD in Electronics. He has a teaching experience of 21 years and industrial experience of 3 years. He has received Best Teacher Award. He is the life member of various organizations such as Indian Society of Technical Education, Computer Society of India, and Institute of Engineering India. He was ex-BOS chairman of ENTC Engineering, Punyashlok Ahilyadevi Holkar, Solapur University, Solapur. He is a chairman of Paper Setters of Solapur University, Shivaji University, and Batu Lonere. He was a resource person for faculty development program and short-term training program in the area of embedded system and wireless communication. He has successfully completed the 36 kilowatt solar power generation on-grid plant work. He is an energy consultant. Dr. Sirwal sir guided 50 projects for undergraduate and postgraduate engineering students. Dr. Sirwal sir has published 9 papers in national and international journals and attended many conferences, workshops, and symposium. He is a reviewer of renowned journals. I hope his talk on wireless technology may become more informative, motivating, and inspirable to us. Thank you. Thank you, sir. Welcome. I hand over to Dr. K.P. Deshmukh, sir.
Thank you, Professor Godke, for giving a nice introduction about today's guest, Dr. Sirwal sir. I request today's resource person, Dr. Sirwal sir, to please take over the charge and start his presentation. Over to Dr. Sirwal.
Thank you very much, sir. I hope I am audible to all of you.
Yes, sir.
Yes. So I'm just sharing my screen. Yes, screen is also visible to all of you. I hope so.
Yeah.
Okay, so really thanks for my nice introduction by Dr. Godke sir, and nice start by the Dr. K.P. Deshmukh. Both of them, they are from since last few days, they are in touch with me and we are talking about the whatever the lecture sessions you have. I'm readily have accepted this your invitation, and I'm very happy to share my knowledge to the students because this is the wealth which we have, which is going to increase if you are going to share to the other people. ठीक आहे. आजचा जरा ऑडियन्स बघून सर मी थोडंसं मराठी पण बोलेन आणि अल्टिमेट एम इज टू अंडरस्टँड द वायरलेस टेक्नॉलॉजी and see when I was in engineering I'm very much afraid about this communication subject, but when I have completed my BE Bachelor of Engineering from Sangli, I have joined into the intercom industry as a design and development engineer, and I have developed one system that is a telecom system that is known as a EPA-BX, Electronic Private Automatic Branch Exchange. It works like your telephone exchange itself, but it is a private. In a big companies, it is there. Okay, so maybe whenever you are going to call to some big companies, so you can receive the message, welcome to the so and so company. And if you know the extension number, please dial the extension number or otherwise wait for the operators. Okay, such an interactive voice response system was there. And see, I have designed this small home EPBX system, designed it, and in the 3 years there, and after that I have joined this noble profession, the teaching profession. But earlier I worked in the industry. Okay, we are not going to the history what which we have. My father was a professor, and then I decided to shift to the teaching, and then I did my MTech and I have pursued my PhD in the wireless communication. See, so really I am thankful to your principal, Dr. B.D. Rebdekar madam, your science coordinator, Dr. T.N. Lokhande sir, then DBT coordinator also Dr. V.M. Puram sir. So thanks to all of them first of all, and good morning to all of you before start of this my session. I am going to present you so whatever the technologies which you are handling. I'm not going to give you the rocket science. But whatever you are using nowadays, see, this pandemic made us to connect wirelessly. See, the today's session, maybe we can able to have the on the offline mode, but due to all the constraints there, so we have arranged so this particular session through this online mode. And thanks to Zoom, and there are so many platforms are there. TeachMeet is there, Google Meet is there, then WebEx is there. So different platforms are there, and so we have used it to share our sessions, share our knowledge to the students. Okay, so just we will go to with this sentence. ध्येयासाठी जगणे हे ध्येयासाठी मरण्यापेक्षा कठीण आहे. कार्यशक्ती आणि इच्छाशक्ती प्राप्त करा, खडतर परिश्रम करा, म्हणजे तुम्ही निश्चित ध्येयाप्रत पोहोचू शकाल. So this is my words to my all dear friends, student friends. My outline of my talk, so just I am going to introduce about the wireless technology. That is some brief history, how the progress has happened in this technology, and different topologies are used in the wireless technologies. Just we are going to see about it, and wireless communication, how it happens there. And my area, special area, it is there. That is my book, multiple input and multiple output. And I'm going to put some lights on the whatever the thrust areas where you can able to work there. And definitely, I'm going to give you certain applications, certain projects which you can do it. Okay, as your hobbies. See, ultimately what is the aim of the today's session is we need to understand the evolution of this wireless technology. We need to know about the whatever the advancements are there, which are in terms of data rate, then the range, the complexity, delay, etc. And we need to identify certain applications which we are using day to day by using this particular technology. And ultimately, after this session, the outcome is the student can use this technology to build a small project. See, wireless, how you are going to describe? The two devices are there which are not able to to connect through the wire. So it is connected through the wireless, and especially they are connected through the electromagnetic waves, which are used for the communication purpose. So basically the technology, initially you know that in your home, so there is a radio station. So there is a transmitter, AM transmitter. So earlier used today the Godke sir and we all before the 3 decades. So we used to listen the news early in the morning from the Pune station, and that it is a AM station where the amplitude modulations which you are learning in your analog communication, that modulation technology made us to transfer the voice music, so from the transmitter to the radio. Okay, so these examples, you know that, see, that is which we are using in the day-to-day life. These wireless gadgets are there. So most probably everybody have this cellular phone with them, right? So when we were in the industry in the back 1997, so there was the pager. Pager is a small device like matches there, and it is one-way communication. So we used to transmit the text message onto that pager, and the person who is going to get it, the message, that is what we want to communicate to that particular person there. So maybe there are certain cordless computer peripherals are there which you are using. Cordless mouse is there, keyboard is there, then headset. Okay, walkie-talkie. So the policemen they are using, traffic police they are using, and many devices are there. GPS unit is there. So these all are examples of the wireless devices. So what are the modes for the wireless communication? So one is by using the radio frequency. Another is by using the microwave. Third one is the optical. Fourth one is the infrared. And maybe we can, using the antenna, we can have the point-to-point communication or point-to-multi-point communication. So especially for microwave communication, so it is for the short range and where the line of sight means, so we can see our receiver from your transmitter end. So infrared, so basically whatever the remote control you are using for the operating your the TV set, and to changing the channels you are using this remote which works on the IR. So it is short range communication. And nowadays, so the optical communication is coming. So maybe for the broadband, so that fiber optics it is there. So it is replacing the broadband. And see, involved basically it is point-to-point, point-to-multi-point, or the broadcasting, the cellular network which we are using in the mobile communication. So this is the brief history. If you can see that in 1879, so the first David Hughes, so he transmitted the electromagnetic waves from the transmitter, so which is in the form of the clockwork key. So that it is nothing but the key technology is used. So you know that. So maybe in the analog communication you are going to learn about certain shift keying techniques are there. That is amplitude shift keying, then frequency shift keying, then the phase shift keying there. Okay, so that is whenever the key is pressed, at that time the carrier wave is going to be transmitted. This is called as the key techniques. But later, so the induction principle was there, and based on that, the Thomas Edison, he used the vibrator magnet for the induction transmission. So in 1888, but the Heinrich Hertz, after that, he first demonstrated the how the electromagnetic waves are travels from one end to the other end. But this is only the demonstration. But the Jagdish Chandra Bose, he designed the receiver part who is going to receive the electromagnetic waves, and he demonstrated that that is how the electromagnetic waves are transmitted, that nature of that wave, and how it should be received. So he given birth to this millimeter length electromagnetic waves, and afterwards the Nikola Tesla, so he made the revolution in the wireless radio communication, and radio control technology there. Okay, so before proceeding to this wireless, so we will see that what exactly the difference between the wired and the wireless communication. See, quite obviously, the wired communication, it is very reliable because there is a perfect connection between the transmitter and the receiver. So therefore, if you can see the data rate in the gigabits per second or terabits per second, and very simply we can able to scale it. We can increase by connecting the wires to the some other devices, and it is a very fast, and the media, it is a wire there. So therefore, to transmit the signal from one end to the another end, it requires the delay is very low. And especially, so the Ethernet cables are used to transmit the data, and it is very difficult to mobilize because once you have set it, so if you want to transfer to the other place, so you have to let down the cables and you have to make that arrangement. So therefore, the installation cost is high. But as far as the wireless system, if you have to design that, so there is a limited natural sources are there because you have to use the radio frequencies. Okay, and these frequencies are going to allocate by the authorization. Some ITUs are there; those are called as the international telecommunication units. So maybe you can see that for mobile. So maybe in few decade back, you have heard about the spectrum Gotala. Okay, so that it is nothing but auctioning of the spectrum. So this Idea, Airtel, the Vodafone, they need to that get the spectrum from this ITU. So they have to pay for that. So definitely, whatever the spectrum allocated for them, so it is very challenge for those vendors to efficiently use that spectrum. And if you have seen that, so in the third generation, the whatever the data rate it is there, it is up to in the Mbps. So it is goes up to the in the wireless LAN up to 100 Mbps. But in the wired, so it is in the gigabits per seconds there. So delay is very high. So it requires a lot of time there. And you need to build a certain networks there to connect the devices wirelessly. So therefore, we need to have some wireless LAN cards there. But here, mobilization is very easily possible. You can transfer the system from one end to the another end. So then you can able to configure according to your wish. So therefore, the installation cost is low as far as the wireless systems are concerned. But wireless systems are there. Those are considered as the fixed wireless and the mobile wireless. In that, mobile wireless and the portable wireless are there, and the IR wireless. So we will go with the examples. So these are the different types which you are familiar with for the wireless technologies. The Bluetooth is there, then Wi-Fi, WiMAX, RFID, and the infrared. We'll see one by one. So this Bluetooth technology invented. So basically, this is the name given by the in the 10th century. The king name was Harold Bluetooth. So he is from the Denmark. So he connected the two nations, Norway and Denmark, and make one kingdom there. So like that, so we can pair the both the devices and you can share it. So therefore, so for this technology, the name of that king is given, that is a Bluetooth. And especially, so for small range, we can use it for exchanging the data between the two devices, and most of the times you are using it. So by using the Bluetooth, maybe you are sharing your files, maybe you are sharing your images, okay? And so definitely it is creating the one network that it is called as the PAN. It is a personal area network, and it is very highly secured because both the devices are paired with certain codes. See, initially, so whatever the Bluetooth version was there in 19, so this evaluation it is takes place. So now if you can see the latest version, it is the 5.2. So earlier in the version 1998, the Bluetooth version was 1.0 and 1.0B. So there they are used the frequency hopping. So maybe you have studied about the spread spectrum technology, which is after the modulation. So in the spread spectrum, so once modulated signal is there, so it is modulated double. Okay, so in the direct sequence, so maybe we can have the amplitude modulation, but in case of the Bluetooth technology, so there they are using the frequency hooping. So the frequency modulated signal, one more. So we can say that it is a double modulation. To just understand, तुम्हाला समजायला spread spectrum technology म्हणजे दोन वेळा modulation केलेलं ते signal असतं. And after that, the 1.0 and 1.0 specification. So there is hardware. What will be the problem? That is hardware interoperability and the compatibility between the different devices. So that is, I can't switch from one device to the another device. So the compatibility was the issue in the Bluetooth version 1.0 and 1.0p. So therefore, in 2000, so first that Ericsson, they have developed the headset which works on the Bluetooth, and they are using the adapter, and from that the data will be received so wirelessly through to the headset. And after that, in the 1.2 version of the Bluetooth, so basically, so it is used to reduce the resistance of the interference which is caused by the some other devices. And in 2003, so this 1.2 version, and it is designated by the IEEE standard as 802.15.1. Okay, and see, basically, so whatever this latest version is there in the 5.2, so the data rate it is increased, that is up to the 3 Mbps, but that is the theoretically, but practically, so we can able to get it a data rate at least of the 2.1 Mbps. And basically the duty cycle, it is possible due to the whatever the duty cycle of the signal, it is reduced there. And definitely for once we have reduced that duty cycle, so the power consumption is also going to be the less. And the data it is more secured by the encryption. So maybe it is the public or the private, and 128-bit or the 64-bit for A5 security, it is used in the Bluetooth technology. So these are the characteristics of the Bluetooth. So it is known as the IEEE standard 802.15. So basically it is intended to create the personal area network. So operating range is very small. It is up to the 10 meter. And whatever the power required for this, it is very less, 1 milliwatt. But the frequency band allocated for this Bluetooth is the ISM band. So it is industrial, scientific and medical. So whose frequency range is from 2.4 gigahertz to 2.4835 gigahertz. Okay, and definitely, so it separates when we are using the frequency hooping, and it is going to create a separate channel, and the interference between the two adjacent channel, it is going to be the reduced. So therefore, so it is a more secure technology. So basically it uses the Piconet. So Piconet, it is nothing but the for through one media, so many devices are connected there. So such a technology is called as Piconet. In the Piconet, we can able to interface the maximum 8 devices, and here very possible to transmit the signals through the walls, and here, so therefore we can eliminate the line of sight. It is not expected that so the transmitter and receivers are visible to each other. So this is without line of sight, we can able to transfer the data from one device to the other device. And basically the antennas used for this, the point communication, it is omnidirectional. So that is nothing but the radiation power in all directions, it is the same. And this Bluetooth, it is worldwide with the same standard. So therefore your device is compatible wherever you are going. So you can able to use it, this particular Bluetooth technology. So therefore the advantage it is there. So there is no line of sight restriction is there. So as the power consumption is less, so we can integrate with the battery system, So the frequency it is there worldwide, the same frequency it is there, which is the 2.4 gigahertz. So we can tremendous the applications are there by using this particular Bluetooth technology in case of the cellular technology and in the transportation. And we don't require to configure the devices. So in case of this Bluetooth, what is the disadvantage of this Bluetooth? So if it is a data rate, it is very low. It is only 1 megabits per second. And definitely the other devices maybe can attack. So which is going to create the interference or intercept it. And if you are more time you are using, so battery it is going to drain. So the battery use is increased if you are using the Bluetooth enabled devices there. And the restriction is we can't use for the long distance communication. So we need to see that how this technology is going to create an impact on the environment. See, one of my friend when I'm doing the PhD, so he done his PhD on the impact of electromagnetic waves radiation on the human being. So he studied about the whatever the base station which are installed in the city. So how that is going to create an impact on the people who are staying nearby to that base station. So he's found out that is what are the diseases are there. So maybe the mentally, physically. So he's tested about the what about the spectrum, how that energy is going to create an impact on the human being. So therefore we need to understand. So these are traveling through the air media and these are going to create an impact on the human. And see whatever the Bluetooth, it is in the microwave and whatever the band which we are using for the microwave oven, we know that the micro oven is we are using it for the heating purpose. But this Bluetooth, if it is interacted to the person, so body is not going to heat. But so continuously, if it is creating the impact on the human body, so maybe it is going to create the irritation to the human being, and maybe the person is not going to tolerate those waves there, right? So maybe you know that these are the different applications of the Bluetooth. So the first picture itself shows that many times you want to share your information through the Bluetooth. May Bluetooth headsets are there. Maybe you can connect through the Bluetooth many computer accessories. Maybe we can able to connect the LAN port and we can able to access the internet there. Maybe so many of the times whatever the now the speakers are there. So we multimedia directly we are connecting to the speaker through the Bluetooth. So definitely without any wired connection, so we can listen to songs through the speaker there. So these are the different applications of the Bluetooth. Next is Wi-Fi technology. It is wireless fidelity. So this is also the one organization. So this is the Wi-Fi Alliance. So which are described under the technology that is wireless LAN based, which is called as IEEE 802.11 standard. So this is basically intended for the computing devices to connect through the laptop, to connect through the different the PCs, desktops there, and where we can transfer the voice over the internet protocol for the gaming purpose and connecting the many consumer devices such as the television and the DVD players. We are using this Wi-Fi technology. So basically this Wi-Fi is for the internet and see, so maybe you can connect the wired network through this Wi-Fi technology and you can able to access the broadband from those devices. So basically Wi-Fi works on the OSI model, the physical and the data link layer in which the Wi-Fi works there. And there are the different standards are there which exist 802.11b, A, G and 10. So what is the main aim of this Wi-Fi? So we have to access the information very easily. So there is the compatibility between the coexistence between the two devices and reducing the complex cabling between the two devices. And we try to eliminate the adapters, plugs, pins and connectors which are required otherwise. for the communication purpose. See, the first standard was the 802.11b Wi-Fi. So that was in 1999. Its operating frequency range is in the ISM band 2.4 gigahertz. The data rate theoretically it is 11 Mbps, but actual speed which we are going to get it is 4 to 6 Mbps. But the range which it covers, it is more than the 100 to 150 feet there. This is the most popular but and least expensive, this 802.11b, and so many interference from the mobile phones and the Bluetooth devices, which will reduce the transmission speed there. Okay. So dear friends, those whose mics are open, please make it off there. Okay, thank you. And you can, if you have any queries there, you can ask there itself, no issue. I'm going to pose you certain questions after the certain interval. आपल्याला मोनोटोनस नको आहे की काही टेक्नॉलॉजी झाल्यानंतर मी तुम्हाला काही प्रश्न विचारणार आहे. ओके, इट इज ऑनलाइन मोड, इट इज देयर. ओके, जस्ट
सर तुम्ही हे करा, अनम्यूट करा. शिरवळ सर.
हो हो हो,
अनम्यूट करा.
येस सर, येस सर, येस सर. Okay, so this is the first standard, and then the evolution was there in 2001. If you can see this operating frequencies, earlier 2.4 gigahertz, now 5 gigahertz. Speed also theoretically it is 54 megabits per second, but actual field speed is the 15 to 20. But the range is the less, 50 to 75 feet. This is a very less popular and more expensive as compared to the 802.11b. And this is not compatible if your Wi-Fi enabled with this, so it is we can't able to use for the 802.11b. It is not the backward compatibility, it is there. But 802.11z, which is in the 2003, which operates on the same frequency, 2.4 gigahertz. The speed is 54 megabits per second, range is 100 to 150 feet. So here the 802.11 combines the features of A and B, but here is the backward compatibility we can use for the 802.11b also. So this is just for your information, what are the benefits of A versus B versus G. So 802.11 in cost wise, the lowest price is there, but 802.11a, it supports the more user, and 802.11g, it supports more user and also the speed is very high. So signal range in the 802.11b is range excellent, so therefore it covers the large distance. 802.11, it is unaffected by the interference from the other devices, maybe from the Bluetooth also there. And in 802.11g, which is backward compatibility for the wireless speed. So these all are as the Wi-Fi, you know that. So it is used for non-line of sight also. So therefore it penetrates to the most of the walls there. So it is coexist between 802.11 between the B and Z network. But 802.11g has having the excellent network. So mostly nowadays this 802.11g is used. So earlier for the public hotspot 802.11b is used, and for limited range in a one room, if you want to connect the many devices, if you want to use the Wi-Fi, so the IEEE standard used there in that case for the limited coverage, that is 802.11a, and for the increase the range, so beyond certain limits there, so we can use the 802.11g. Very important it is there for this Wi-Fi, whichever the devices or the elements are required. So definitely we require the access point, which is act as a trans receiver or the base station, through which we can able to connect the many devices. See for this, so what the terminal or your laptop, so it should have the card that is called as the Wi-Fi card. For example, we have the PCMCI card. in case of the laptops, and in case of the PSI, that is personal computer, so PC, we will have the PCI. But for the safeguard, so definitely we need the certain firewalls and the antivirus software which are going to protect your network from unauthorized accessing your particular devices. Okay, so this is in short the summary it is there. So 802.11 and it is a globally. So there the further versions are exist there, and their data rate is very high, and frequency either they are using the 2.4 gigahertz or the 5 gigahertz there. Okay. So how to connect the Wi-Fi network? So definitely we require the access point through which we can able to connect all the devices. Maybe your the multimedia, maybe your phone, maybe your desktop, maybe your PC, maybe your tab or notepad, or any devices gadget we can able to connect it. See, basically there are the topology which are used to connect these devices. So this is the access point based topology. So we have the access point, and through that which, so whatever the gadgets which are available in that particular area, those are connected with each other. So it is called as the basic service area, which that access point covers through the radio frequency. And if you want to extend it, so definitely if you want to cover the other area also, so we have to extend our service area by deploying the one more access point over there, and we can communicate through that access point to that particular area. So definitely in this case, so there are the certain areas are there, those are going to be overlap for the access points 1 and the access point 2. Or maybe we can able to have the peer-to-peer communication. So that is one-to-one communication. But for that, we need the network interface card should be there in your device there. So which is going to create the ad-hoc network, and through which, so we can able to access the devices, maybe the printer, or maybe you can share the files. So this is the called as the wired less LAN, and we can connect through the wired LAN also there. So which is going to act at the bridge between the wireless and the wired LAN. Okay, so very important it is there. So that is a security, which in the wireless network it is there. So we can able to maintain the security by these 4 methods, either by the data encryption or code-based access control, or SSID, that is service set identifier, or the media access control, that is a MAC address filtering there. So the first security, that is the WEAP or the WPA, that is called as the wired equivalent privacy or the Wi-Fi protected access. So these are suitable for very small network. Here basically we are using the encryption algorithm. What is the encryption? Encryption is nothing but the one key which is added with your data message, so that we can't able to demodulate that message. You can't able to get it whatever the transmitted message exactly it is there. Okay, until you know that whatever the encrypted keys are there. But this encrypted key in case of this wired equivalent privacy is static. Okay, it is constant, it is not going to be changed. And so there is no mechanism for user authentication. So I can able to give to anybody, he can able to use it. So, but whether he is a valid user, that authentication is not possible. So therefore, it is little bit difficult to maintain the security. But in the Wi-Fi protected access, so we, the whatever the keys are, encryption keys are there, those are dynamic. So those are changing, and the user authentication is possible through the protocol which is called as EAP. So that is extensible authentication protocol. So through that we can authorize the user there. Another security is there, SSID. So SSID we are using in the mobile. So it is a 32 character which is associated with the whatever the packet which we are sending. So once somebody is transferring the data, so that in the header his SSID 32 code it is there. So therefore we can able to find out the mobile if it is stolen by somebody else it is there. So you can configure your access point through your SSID name, right? So if you want to configure your mobile with your broadband, so you can configure the SSID with your access point. Another it is there in case of your desktop or your laptop. So those are filtered out through the MAC address there. So because for your laptop and the PC, so we are having the unique address, and through that, so we can communicate to the other devices there. Right. So port based access control. So that is, so for particular port, so if you are connecting your device, so that is part of the 802.1x standard it is there. And so definitely, so that hardware must be compatible for that, and the authorization and the configuration both will be done by that particular server, and then the user enabled network can able to use that port it is there. Okay, very important components which are required as far as the Wi-Fi technologies are there. So those are the medium access point and the extension access point, whatever the wireless bridges, antennas, wireless adapters, wireless station and server, and certain software. See, medium, so we know that it is the unguided form of network medium. So for certain technology, wherever the distance is small, so there we can able to have the Bluetooth, infrared, laser, radio signal, and this microwave technology is there. And mobile computing we can able to use for the long distance, and by using that, so we can access the data from anywhere through the internet. So we will go by this the whatever the devices or components are there in the Wi-Fi access point. So it is the transceiver, so through which we can connect your wireless device to the wired network there. So maybe there is a hardware access point or the software access point. So maybe you can connect the compatible device to the modems there, or maybe you can access through the configuring the software in your gadget, and there is a connection between the your device and that device. So extension point. So if you want to increase the area, so definitely we need to have the one more access point at that place, and so that it can increase the coverage area. Okay, so this is the software access points. So which basically includes the NIC card in your the laptop, and through that, so it is going to configure the all the drivers and utility software, so to properly functioning the whatever the hardware connected to your laptop. So maybe you know that, so any new devices when you are connecting to your laptop, so that hardware it is going to be the configured by your OS. So it is not going to immediately accepting and giving the service to you. So first of all, that device is going to be configured, and once it becomes a compatible, so you can access those devices. In the hardware access point, so the physical device is there that is used to establish the connection between the wired and the wireless network. So these are the devices are there. So this is the wireless bridge, and the another device it is there, that is the power line bridge. So which is used to penetrate the signal from the non-line of sight also. Okay, so antennas are very important, and adapters as far as this Wi-Fi communications are there. So there are the two types of the antennas. One is omnidirectional and another is the bidirectional. So for indoor communication, so where is line of sight it is there, so there we are using the omnidirectional antennas, and wherever the outdoor, so where the non-line of sight it is there, or the for long distance communication, we are using the directional antennas. And definitely if the strength of the signal is low, so maybe we have to install in between the transmitter and receiver some repeaters to increase the gain of the signal. And so certain wireless adapters are also help to connect the computer or the personal digital accessories to a network. And so whatever these wireless adapters are going to connect to your PC cards, PCI and mini PCI or USB or the compact flash system. So what are the problems are there? So for this Wi-Fi, so the first that is there, so we have to configure the whatever the devices which are connecting to these particular networks. So we have to have the driver compatibility. And if the low signal strength it is there, so definitely it is going to cause the interference by the some other devices. So therefore we need to install the repeaters. And we to increase the directionality, so we have to have the antennas, those direction we need to change it. And sometimes we have to update our OS also, that is we have to install our Windows. And in case of the networking settings, we have to have for the security SSID setting sometimes, so that is DHCP setting, or the encryption keys you have to change it, or you have to have the MAC. So these problems are exist. If you have seen that when you are connected to your Ethernet card and you want to access the broadband communication, so sometimes due to this setting, if some ports are IP addresses are changed, so definitely you are not able to get it, the access from the broadband. So in nutshell for the wireless networks, so this wireless plans belongs to the Bluetooth, that is IEEE 802.11. So that is wireless personal area network. Wireless local area network, it belongs to for the Wi-Fi, that is wireless fidelity. And in the multi-hop ad hoc networks, so maybe we can have that the wireless MANs, so that is metropolitan area networks, so that it is a 802.16 standard is there. So this is the typical structure of the wireless MAN. So where the certain base stations are there, you can see here. So this is a base station. This is one more base stations are there. So these are the core system. So through which the signal is transmitted to the many receivers. Okay, so maybe the signal strength is low for these residential customers. So there in between that there is a repeater to just to increase the strength of the signal. Okay, so typical technology is required. So base station should be installed, and through that, so the other devices will get it the service through the base station. Okay, so based on this technology, so the revolution made in the wireless by this technology, that it is known as the WiMAX. Okay, so it is World Interoperability Microwave Access. So which is given birth to the different generations of this mobile communication. And this made it possible to access the high-speed internet to the many homes or the business subscribers. But for this WiMAX, we need to install the base station, that is a mandatory. And through this centralized access control, we can prevent the collisions of the data, so from the different subscribers. So you know that how this mobile, though we are talking from one subscriber to the another subscriber, so there is no any directly connection. So your signal goes to the base station, which belongs to that particular cell area, and then so it is diverted to the another subscriber to whom you want to communicate that. So definitely here, so the parameter it is there, the quality of service. So quality of service means the whether the signal strength, whether clearly you can able to receive the voice at the other end. Maybe there is an interference, or maybe there is a collision. Many of the times it happens in the network, you might have observed that. And whatever the standard by the IEEE mentioned for this, it is there, it is a 802.16. Okay. So this is basically the alternate wireless technology for the Wi-Fi, which is to connect to the wireless networking without the cable and the DSL. So the IEEE, what it stands for, it is the Institute of Electrical and Electronics Engineers. and they are deciding the standards of the technologies there. So basically, this is the non-profit organizations. They came together to develop the technology and to develop the product which are compatible to each other. So we can exchange those products and those are compatible to all the technologies there. And this is possible due to the different the taste they have planned and different certification programs, and they have shared whatever the development they have made in context with this WiMAX. And therefore, so the many companies which are part of this WiMAX, so the all the equipments are compatible to this technology. So therefore, the whatever the customer can buy, the very confidently the equipment from any the uh, seller there. So this Max technology, so there are basically the line of sight, it is the requirement for other, but see for this mobile wireless broadband connectivity, so we need not to have this the line of sight. And basically the base station and the mobile stations, though they are not in a site, they are not visible to each other, but we can have the connection between the mobile station and the base station. But the data rate, it is a limited, so that is the 40 Mbps per channel. But practically, so when the capacity or for the deployment for the long range, so of the radius of 3 kilometer, so we are going to get it the data rate of the 50 Mbps. Okay, what is a very interesting it is there. So very interesting it is there. So we can accommodate the large number of subscribers by using this WiMAX technology. So that it is nothing but we can able to use the efficiently the whatever the bandwidth allocated for WiMAX by accommodating more number of subscribers in that particular band. And so this is the cost is very low and which is a flexible to build a broadband network. And we can increase the channels there by increasing the base stations. Okay, suppose if more subscribers are increased there, so we can add one more base station so that we can give the service to those subscribers belongs to that particular cell. Okay, so if bandwidth grows there, so that is within the particular bandwidth, if you are unable to accommodate the subscriber, ultimately solution is there. So we can have the one more base station in the same cell, and that can give the service to the other subscribers. And this is the supporting to the 3G and the 4G technology, where so in a earlier years, in a year 2003 or 5, so this video conferencing technology, so that is happened, and we can talk, we can conduct a meeting through this video conferencing through this particular WiMAX. That is the upgradation in the mobile technology. Okay, so just I'm briefing at the end there how this wireless communication grows from 1G to the 5G there. Right, and so in a year 2006, so many companies they have manufactured the WiMAX enabled the devices such as the notebook computers and the PDS. Okay, so if you want to correlate this WiMAX and the Wi-Fi, okay, whatever the constraints of Wi-Fi are there, those are little bit removed by the WiMAX, such as the bandwidth, the more number of subscribers, the interference, such all the things there. Okay, and very to be specifically, the WiMAX is intended for the outdoor application and for long distance communication there. And it is little bit more complex technology there. And definitely the issue is there, the quality of service. So whether I don't know that the transmitted signal it is going to receive faithfully at the receiver, it is depend upon the whatever the carrier and its reliability and the whatever the non-line of sight. So therefore, so it is not, it is like that. To replace the Wi-Fi, we have the WiMAX. So Wi-Fi has its own advantage, WiMAX has its own advantage. these both the technologies are complementary to each other. So this is the evolution of the WiMAX. And if you can see in the 802.16e standard, so though the spectrum having of the less than 6 gigahertz, so there is non-line of sight and the mobility, and the data rate, though it is less, it's a sufficient 15 Mbps. But the advantages it is that so more number of subscriber we are accommodating by using the different technologies, but the range is the radius, if you can see that it is 1 to 3 miles. So this is the typical structure of the WiMAX. So how it is for the non-line of sight and the line of sight. Okay, maybe you can see here, this is the fixed black hole. So where this signal is not going to be the come down. So this is called as the black. So we can able to communicate through some another base station through the internet. So maybe this is possible by deploying the various base station and the communication with each other. So for the non-line of sight devices and the line of sight devices. So maybe by using the hotspot or maybe some the gadgets by receiving antennas, so we can use the signals, that connection between the subscriber and the base station. Okay, so there are the two services which the WiMAX is going to provide. So one is based on the non-line of sight and another is based on the line of sight. So when it is non-line of sight, so we should have the smaller antenna which are connected to the base station, and that station so is going to communicate to the users or the subscribers, but the frequency range is from 2 to 11 gigahertz. But when it is a line of sight, so that it is nothing but the mobile users are in sight with the base station antenna. So therefore the connection is very strong, and so we can able to transmit the data with a very high possible rate of the 66 gigahertz there. And see, we can accommodate the more subscribers in this particular line of sight, because there is a strength of signal that is very strong, but the radius it is restricted up to the 30 mile there for this particular the antenna which radiates in the omni direction. So these are the three phases where the WiMAX it is going to be the rollout. The first, it is there in the fixed location and the private line services on the hotspot. Phase second, it is the broadband, and the third phase it is there, it is the mobile or the nomadic users there. See, WiMAX it operates in the three different frequency bands there. So some are licensed and some are unlicensed there. So according to the country wise, if you can see that, so the 5 gigahertz, which is the unlicensed frequency band, and the power output is also very high. It is 4 watt, so which is more attractive for the WiMAX applications. But some countries, so they are using, for the majority of countries, they are using the licensed frequency band of 3.45 gigahertz. So actually that band exists from 3.4 and 3.6 gigahertz. So in between 3.4 to 3.6 gigahertz. And another, some other countries like the US, Mexico, Brazil, and the Southeast Asia countries, so they are using the licensed 2.5 gigahertz. Okay, so I can say that for the WiMAX, the licensed frequency bands are 3.5 gigahertz and 2.5, and unlicensed it is there, it is 5 gigahertz. Okay, the question is, so whether we have to go for the licensed or the unlicensed there. So if definitely you need the good quality of service, so definitely we have to go for the licensed. And if you don't want to have it, so definitely there is many license you can use it, because the cost is very low and more worldwide options are there, so we can use it those. But wherever the non-line of sight it is there and low frequencies are there, so we have to have the licensed frequency band. So it is going to create the highest barrier for the entrance. So that is, who is not going to have the license, so he is not going to be able to use that particular band. So therefore, we can able to restrict the user to access that particular frequency. So basically, in the licensed and the unlicensed band, so both are using. So the solution is the standard 802.16 2004. So which uses in the physical layer, that is whatever the mobile technology nowadays, they are using this multiplexing technique, that is OFDM, orthogonal frequency division multiplexing. Ultimately what it does there, so maybe you have studied, that is time division multiplexing, frequency division multiplexing, code division multiplexing. But now whatever these generations are there, so they are using the orthogonal frequency division multiplexing. So that is the total band, it is divided into the different carriers, and they are having the different carrier slot, and through that we can able to transmit the data. So what is the advantage of this OFDM in the mobile technology? So that it is increased the SNR. SNR is nothing but the signal to noise ratio of the different subscribers, and it removed the multipath interference, so which exists between the two. See, now whenever the signals are transmitted, so I will take it ahead. So just I will show you afterwards. See, for bidirectional channels, so basically to communicate with this, so we require the channel. So there is the duplex system. So we can transmit, we can receive there. So for that we require the uplink and the downlink. Okay, so whenever we are having the from mobile stations to the base station, so it is uplink, and when the data flow from the base station to the mobile station, it is a downlink. Right. So for the licensed, they are using the FDT. Okay, frequency part it is there. Okay, duplexing, and it is a time for the unlicensed or the non-licensed. So for the time division duplexing, so there is only one channel is used for transmitting the data as well as a receiving. So therefore we can be able to either we can transmit data or we can able to receive it. Okay, and both the sides, so we require the pair of smart antennas, and the whatever the data it is there, it is the data rate it is there for the uplink and downlink, it is the asymmetrical. We can't have the same frequencies for the uplink and the downlink. Okay, the disadvantage is the same. So we cannot transmit and receive at the same time. Either we can use it as a transmitter or we can use it as a receiver. Okay, so wherever the burst data it is there, or lot of data, asymmetrical data application is there, if you want to transmit, so you can able to use this time division duplexing. So in the frequency division duplexing, so we have the separate the uplink channel and the downlink channel. So this technology is used for transferring the voice, data, and this is a symmetrical traffic, and it does not require the guard time between the two signals. So it is not going to overlap there. So it is going to accommodate the more data as it doesn't require the guard time. And here, so we don't have the two antennas which are paired with each other. So here the unpaired technology, and basically whatever the spectrum which we are using, that should be the licensed for there. And what it restrict there, so whatever the traffic which is there in that particular cell, so which is going to decide the complexity of the system, and which may increase the cost of that particular the system there. Okay, right. So now what are the challenges are there for the WiMAX? So the RF interference. Okay, so see, it is due to the many signals coming together at the base stations. So maybe they will add constructively or destructively, we don't know that. and that when adding or overlapping with each other, so maybe they is going to create the random noise. Okay. So therefore, to avoid this RF interference, so we should have the infrastructure placement very properly there. The physical structure of whatever the buildings are there, and that you need to consider while installing the base station in the particular area. Or maybe the other or also reflector, maybe trees are also there, which are going to create an obstacle for your base station. See, basically the typical structure. So just I'm going to share the little bit my whiteboard. So maybe that is visible to all of you. See what it is. So this is if your base station, right? And this is your mobile station. And this is your base station. Okay. See, so this is the mobile user. So this is a fixed, and see the signal will be transmitted from this. So directly. So maybe we can have this is the directly to this mobile. So we can say this is the line of sight. Right. Maybe there are the certain buildings are there. Okay. So the signal will impact on this building and then it will comes to this mobile. So this is your non-line of sight. So maybe there are the trees are there. So many trees are there. So they will the signal will impact because this whatever the antenna used at the base station. So it is the omnidirectional. In all directional the signal will close there. So the reflection will occur. So this is non-line of sight. See, so the same signal it is transmitted through the different paths. So this is called as the multipath, and those are added together to the mobile. Okay, so this is called as the multipath interference, and this signal is going to create only one signal by adding together. So whatever the signal which is going to add here, so maybe it will add constructively, because maybe it will increase the strength of the signal by adding positively together there, or maybe so it is a destructive, maybe it is going to reduce the strength of the signal. See how it is going to create an impact. So definitely the less time is required for the signal which is traveling from this base station to this through the line of sight. So there is a little bit delay, so which is having through this path, right? Maybe I can say this is the first path, right? And this is the second path, so which is signal reflected through the building, and this is the third. So this delayed signal which is going to create a phase shift in the signal. Okay, so you know that if it is 180-degree phase shift, means that signal is going to become a negative there, and definitely that negative signal and positive signals will add together, so it is going to decrease the strength of the signal, right? So therefore, so what we need to have it, so we have to have the survey of the area where the signal which is coming from the base station to the mobile user, so it is going to add the constructively, and it will try to avoid the interference from so many objects which are vicinity to that particular base station. Okay. So therefore, to solve this challenge, so we have to have the site survey. You have to gather the statistic. So that is where I can able to get the more signals after the reflection from the neighboring providers also, because in the one cell maybe we have the another base station. From that maybe we can create an interference. We have to see that, and you have to decide. So maybe you have seen that the whatever the mobile towers are there are the different antennas are there. So which are with the different angles to increase this its gain, that is array gain, and or the diversity. So diversity means there are the multi paths are there. So that path gain, maybe one path it is not going to the proper there, we have to discard it, but there is a proper connection between the mobile station and the base station by at least one or the two paths there. Okay, and so we have to deployment of the base station, getting the NOC of the others cell which is having the base station into the vicinity of that, and definitely that base station have to have the access provided 24/7, and it is RF friendly structure. So we need to have the certain shielding, so which is not going to create an impact for the environment for this RF. Right. So orthogonal frequency division multiplexing. So it is giving the advantages that, so we are accommodating the utmost the 256 carriers in one OFDM, and we can able to connect to the many devices there. And so it is adaptable for the long distance and the non-line of sight scheme. So it is very resistant to the multipath effects there, and it is very efficient spectrally. That is, whatever the spectrum allocated for that mobile communication, we can able to accommodate the more number of users. Okay, and if suppose many of the times if I'm going to get the message, so there is the congestion in the network, kindly try after some time. So definitely you are going to become panic and you are going to disconnect that particular vendor. Okay, so therefore it is a prime nowadays. So the new technology it is there, so that it is the software defined radio. Suppose in the same there are the two vendors are there. One is Idea and another is a Vodafone. And I am the user of Idea. So that is I am the primary user of Idea. And see, I am dialing the number means, so definitely my connection it is going to establish from the base station of Idea to my another subscriber. But if the channel is not free, if that bandwidth is accommodated by all the subscribers, so definitely what is expected that, so the no network is available to you. But at the same time, so another cell which is in the same cell, which is the another base station, it is there from the Vodafone. He is my secondary user. So the channel is free from that. So definitely, so I am going to shift to the Vodafone, and Vodafone will provide the service to me, and then the connection happens between the mobile and the another subscriber. So it is through the base station of the second vendor. But definitely the Idea has to pay to the Vodafone because they have allowed you the channel to use it. Okay, so this is the technology nowadays. It's upcoming because there is a scarcity of the bandwidth. So bandwidth is a fixed, right? And but you know that day by day the number of subscribers are increasing, the number of mobile users are increasing, and they are encouraging about the data. So therefore, so this is the way to just to address, to just to accommodate the more number of users, and efficiently I can able to use the allocated bandwidth and the spectrum. Okay, so this is the OSI model which we are using, but the 802 standards which using the physical and the data link layer. Okay, so these are the certain benefits of the OFDM technologies are there. Okay, so there is little bit constraint of time, so I'm not going to cover about this physical structure and the MAC layer structure. So okay, because there are the two still more wireless technologies are remained, so that I want to cover them. Okay, so this is very simple. So there are the applications of the WiMAX are, so in the gaming, multi-layer gaming, then VoIP, so the video conferencing we are using, streaming the media, okay, web browsing and the instant messaging, media content downloads. Okay. So what are the advantages of this WiMAX in the nutshell? So it is used for the large distance and for good quality of service. So we can have the very high bandwidth applications wherever we require. We want to send a very high data rate, so we can able to use it, and so we can enable the different applications. So by using this, what is the conclusion behind it? It is, so we have to have the wireless MAN for this particular using if you want to use the WiMAX, and these WiMAX products are there, which are delivered by the many vendors. So those are compatible, and so we need to install those devices, which we have to have configured with the other devices. Okay, so what is there? So always we are focusing on the technology, but whatever the subscribers are there, so they are not paying for the technology, they are paying for the services. But the technology enables the services, but it should not be burden on the users. The user can readily accept that technology and easy to use for them. So we need to design the system so the technology easily used by the user. Okay, so the small quiz for all of you. Okay, you can give the answer on your own there. The scatter net is a combination of, okay, I have talked about the piconet. Okay, the scatter net is actually the multiple piconet it is there. Suppose if I want to have the one piconet, so there is a one master, so which is connected to the all other slave devices in the one node. It is like this. Okay, but this slave, so maybe with this another master, so which is connecting with this. So these two nodes are connected, these slave devices, these are the master devices, and through this we can able to connect to the another piconet. So there is, in the scatter net we have the multiple piconet connection. Okay, the answer is multiple piconet. Okay, the Bluetooth device uses which techniques? Okay, it is not possible you to unmute yourself, but you can give the answer on your own. There is the frequency hopping technique. Okay, a dash node is a node from which data is being sent. So from which node it is always sent? Just I have told you, that is data, it is from the master node. Okay. Okay, what will be the frequency range for the Wi-Fi? Is around from 2.4 gigahertz and 30 gigahertz. Okay, so what the WiMAX uses which standard specification? 802.16b, 802.16g, 802.11a, both 1 and 2. The answer is both 1 and 2. Okay, right. So the just we will go for these two technologies. So I will finish in a 10 minutes. Okay, with now almost it is 12:28. So is it permitted, sir? So just I will. Okay, okay. See, first the very old technology is there. So therefore I have just taken it at the end there. That is RFID technology. It is radio frequency identification. So basically this is used in the Bird War 2 in 1973 to just to identify, so whatever the planes are there, whether it is from the friend or whether it is from the foe. But for this RFID, so we require the RFID tag, then the RFID reader. So just it is used for the application where you want to track or identify the certain product. So the key components for the RFID is the RFID tag, RFID antenna, RFID reader, and RFID station. And nowadays you know that in your vehicle, so in a four-wheeler, so for the toll pass, so we need to have this RFID tag, which is enabled, right? So that it is connected to that. So you need to pay the money there for the toll there. So it is deducted from your whatever the account it is there. But the connection happens between the toll station and your car. It is through this RFID tag. Okay, it is like a paper tag which is you are sticking on the front end of your car. Okay, so there are many. Maybe you are familiar with this key tag. So maybe this is the pocket tag for the in the industry, to just for the attendance purpose. Correct. So these are the different antennas are there. Okay, so simply this wired antenna. Okay, so different directional antennas are there. So maybe in the toll you have seen such a type of the structure which is used to read the your tag there. Okay, so some old places. So earlier, so there is RFID reader. I have to go there and I have to show my RFID tag, and the RFID reader reads it. Right. So in earlier some hotels there to open the doors there. So just to insert that, and then automatically the lock it is going to be opened. Okay, nowadays this is also the use there when you have seen this gadget on the toll booth uh, road on the road there. So if it is not scanning properly there, so they are doing with this device there. So it is a RFID readers. So there are RFID stations are also there. So to read your the tag, and you have to access certain data. So maybe in the library you can access the books there through this RFID tag. You can access the library. Maybe the person identifications will be happen through this RFID there. Okay, when I had been there in long back in 2015 to the Sweden, so I had traveled through the trains there, but I need not to pay there. So I have the RFID tag with me, and nowadays you can see that such a structure in the metro. If you have traveled in the metro in Mumbai, Bangalore, or recently we have started in Pune, so they are giving you the certain the coin like the chip it is there, and when you are at the destination, you are reaching there, so you have to put that coin. So then and then only your the gate it is going to be open, and then you are coming outside of it. But here in these countries, they are using the RFID tag there. So only we have to put onto that machine. So the machine, it opens the door, and then we have to come out of it. So basically we need not to, so where we have entered and where we are that is living. So here is the one applications we have built when I came back from the Sweden. So this idea came in my mind. So my students, they have developed one project. So RFID based bus ticket reservation system. Okay. So I have to have the user. I will allocate the RFID tag to that user. And in that RFID tag, so I will have the certain amount of money he is going to pay. Jasa atta आपण so using for the toll booth there, right? So we will charge it. So certain monies are there in that. Suppose if I want to travel from one place to another place, so there is the ticket. So now in local, so many people they are using, they are taking their own tickets, and by traveling with that ticket, instead of taking the ticket there, so we have to have the RFID tag with us. So with that, so we have to book the ticket, and we have to keep the RFID, and the conductor, he will see that the RFID tag, and he will see that whether he booked the ticket from the source to destination or not. Okay, and very good that project works there, and in many competitions that project got the first prize. So basically, see, whenever we have to observe such a things there, so try to implement into the certain applications there. Right, in the last part I am going to talk about the applications there. So this is one of the application, that is unmanned bus ticket reservation system. So you can able to track the people, you can track the documents, so you can see the, you can monitor the health of the patients through this. And in the manufacturing industry, so you know that this RFID tag it is used. Another wireless technology it is there, that is an infrared technology, so which use the electromagnetic energy. So through the infrared rays, which is invisible. So infrared, it is infrared. Infra means it is a below. So as it lies below the red frequency band, so therefore the wavelength of this infrared below red it is there. So therefore it is called as infrared, and this is used for the short range communication. So for very small range, that is up to the 5 meter, and it works. So you know that your remote control uses this infrared. So very typical structure is there. So there is a one transmitter and another is a receiver. So they are using the LEDs and photodiodes are there. Those are receiving that light. It is there. Okay, so simply both the transmitter and the receivers are of the type of the LED, right? So in many applications, this infrared is used there in the remote control TV, smartphones, printers, PlayStations, image scanners, home security. See the barcode reader, it is there. So they are using also that. Okay, so you can build the many applications by the infrared. So for the counting purpose, okay. So if you want to count in the industry, so many components have manufactured from the machine there. So maybe you can put that product on the conveyor belt there, and when it is going to cut your infrared, right? So it is going to generate one pulse. So that pulse you can able to use it by counting by using the microcontroller, and you can able to display on your display. So those many components are manufactured now, or maybe the person who entered in the hall. So you can count the persons entered in the hall. So what is the disadvantage in that case? If the person leaving the hall also, that it is going to count, it is there. But what you should have there, if there is only one entry and one exit, it is there. So it works very finely there. Right. Maybe this infrared red we can use for connecting the printers there. Okay, you can send the text and the text it is going to print over there. Right. So in the image scanner it is used. All right. So scanning it is done through this IR, and mostly it is used in the home security system. So whenever it is going to break the IR, so maybe the alarm it is going to be the blows. So which is going to secure that particular the gadget or particular the equipment there. Right. Okay. So in short, these wireless technologies, what are the advantages? Okay, you can able to jot down very easily there. They are very easy to use as we don't require the cables there. So always it increases the productivity, convenience, cost as per the customer need based on the technology, and it is going to surplus the whatever the traditional wired technology is there. So it uses the different access technologies are there. Maybe the wireless, so multiple access technology that is for the different applications. So the time division multiple access it is used in the telephone systems there, right? The orthogonal frequency division multiplexes they are using in the mobile communication, right? And there that code division multiple access is also used in the CDMA technology in a 2000 in year 2000 that came there. And wherever the cables are not possible, there you can able to use these wireless technologies. And very in the less time, so you can able to implement or configure the system at any place there. And you can provide the extension for the broadband by deploying the extensive access point over there, and you can increase the range of that. And there is a greater flexibility. We can able to accommodate the more number of users if you needed. Okay, so IR technology. So it is in the remote control, RFID for the item tracking. So GPS system it is used for the navigation and the location identification. So nowadays we can use this wireless to transfer the power also there. Okay, so maybe we can able to charge the mobile without wire. So we can able to monitor the certain parameters by using this wireless technology. Maybe you can able to monitor the health of the patient. Okay, so, and maybe wherever the some disasters are there, maybe the earthquake. Okay, such a management we can able to do it by using the wireless technology. Okay, so the question is, so basically the tags which we are using in the RFID. So there are the two types of the tags are there, active and the passive, basically broadly. In the active tag, so there is power supply. Okay, but in the passive, we need to have the externally power supply. So it is powered there. So the question is, which tag does not have its own power supply? The passive tag does not have its own power supply. Okay. So, sir, in the barcode, if you have seen, if you want to read it, so there is the EPC standard, it is there. That is the code, it is embedded into the particular RFID tag. So that is called as the EPC. That is nothing but the electronic product code. Okay. So that is embedded in your barcode. So that will be identified and that will be shown on your desktop. Maybe the whatever the cost of that book or the cost of that particular item, it is going to be displayed on your desktop there. And these infrared signals, which are used for the very short range communications there. Okay. So it is for the maximum distance, it is of the 5 meter there. Okay. So these are the different areas are there of the wireless communication. So nowadays, so maybe the future radio access technology. So maybe you have heard this word, the Internet of Things, green energy. So that is saving the power there. Convergency means so we can able to communicate to any device, anywhere, anytime. Okay, that is called as the convergency there. Right. So this is the vision by the Marconi in the 1932. So that is, we can't put the limit on the wireless. Okay, so which is a dangerous. So we can share the more devices there. But my mentor, my guru, Professor Ramji Prasad, who is a director at Dalburg University. So he had put it in the year 2005 that. So it is a very dangerous to put the limits on the data rate. If you can see that day by day, the data rate it is increasing. So that is in 2005, we can able to transmit the data with 1 terabits per second. Okay. So that is the advancement in the technology which is happening. It is in the terms of the data rate and in terms of at the same time, whatever I'm going to transmit it, maybe the video, multimedia, okay, all that thing. So there are these certain standardization forums are there across the world, which are the authorities who are going to decide the spectrum for the different users there. Okay, and they are allocating the frequency bands for the different applications. So there is the International Telecommunication Union. This is called as ITU. European, they have the ETSI. It is known as European Telecommunication Standardization Institute. ERIB is also there. Then TIA is also there. But in India, so we have established in year 2009, that is known as the GISP, who decides the standardizations as far as the wireless communication, which is concerned with India. So there are all the partners are there. Tata is there, Jio is there, Airtel is there. They all are the part of this GISP. It is Global ICT Standardization Forum for India. So the head of this is our Professor Ramji Prasad. I am also the one of the member of this standardization forum, and they have led the research area in front of us, and I can able to do in the area of the future radio access technology my PhD, and I have designed the MIMO decoder, that is multiple input, multiple output. So that is, you can see that the mobile size it is goes on decreasing, but so we need to address the power consumption. So it should be utilized right properly. So that battery should be utilized for the whole the day. So though I am accessing the so many applications there, and see the whatever the antennas are there. So there are the multiple antennas are there in your mobile, right? So maybe they are at the same distance. So maybe you know that at least they should have the lambda by 2 by each other there. And so therefore it is multiple input and the multiple output. So that's all in direction. So these multiple antenna transmit and multiple antennas are receiving at the receiver. But ultimate aim is that So those are faithfully added, constructively added together in the mobile, and I can create the very good signal at the mobile station. And definitely to how to process that data, so we need to design certain processor who will access these all the data from the different channels there. Okay, so this is about the evolutionary technology in the mobile. In the first generation, so if you can see this, the advanced mobile packet system, so the data rate it is very low was there, so which is established in the 1981 14.4 kbps. After that, that is global system for the mobile communication came. So that is the second generation. The data rate increased by the 10 times. So it is 144 kilobits per second. See, this is a revolution is very fastly. You can see that. So how the upgradation it is there. See, when I did my engineering in year 1997, so you can see that at that time only GSM was there. And in my home, I don't have the landline connection at that time. When I completed my engineering, so then in year 1998, somewhere else, we could able to get it the landline connection. Okay, so the in the mid between the 2G and the 3G, there are the 2.5G and 2.7G, that is global packet radio systems out there. Then CDMA technology comes in the year 2000. There little bit increased data rate was there, that is a 200 kbps. And in 3G technology, so where the video conferencing was possible by using the wideband code division multiple access and CDMA standards there. So the data rate it is up to the 384 kbps. But nowadays, so you can see that in your mobile, so you can have the long-term evolution. And at the same time, the WiMAX was there because to get the high data rate, and that is given the birth to the LTE also, that and HSDPA, high speed data packet access, that is up to the 100 Mbps in year 2007. But now the IMT advanced application and the LTE advanced system, that is a 4G, which gives the data rate of the 1 gigabits per second. So therefore, that is very crucial to have the data at the mobile. With this data rate, lot of data it is coming. So therefore, so the backward compatibility, so maybe in the 4G we can able to accommodate the 3G, right? But now if you are going to shift the 5G, I don't know that definitely your 4G, 3G is going to obsolete. You can't use the 3G because so it is depend upon the device, and the device is not going to be the configured there. So it is not a backward compatibility, it is going to happen. But now we have the 4G and the 3G compatibility, but in some mobiles, so the 3G is not operating also. That is whatever the new mobiles are now, because almost all the vendors they have shifted to the 4G, and those base stations now they are giving the service to the mobilers, those who are having the 4G. Okay, so you know that the data rate day by day increasing, number of subscribers are increasing. It is a great challenge because the bandwidth it is going to save, spectrum it is going to be same. We are not going to increase there because the allotted bandwidth and the spectrum it is a constant, but it is ultimately the researcher or you people, you have to decide that how I can able to use faithfully, efficiently, whatever the allocated band to me. Okay, so these are the ways there to improve the spectral efficiency. One is the multiple antennas, which I have told. Maybe we can able to have the relaying base station operation. Another is the heterogeneous network grading down. So we can increase the communication between the base station and the mobile user. And another it is called the software defined radio, or it is called as the cognitive. Okay, so this is the technology. I'm not going to talk about the MIMO. All right, so this is where in the research which I have done it, and this is the seed which is given me the initialization to do the research there. Earlier, I have done the work in the VLSI technology, and I have deployed certain systems in the VLSI, and making together with the wireless technology and embedded system and the VLSI design. So I could able to work very well in this the wireless communication. So basically I have done it. So increase the speed. So I have seen that the independency of the data and those data I have captured and I have processed it in a short span of the time. And I have optimized the hardware. So that is, I have reduced the space there. So in a single chip, I want to try to implement all the systems in a single chip by using the VLSI technology. Okay, so this is the second most last slide it is there. So these are the motivation peoples which in my life. The first is Dr. APJ Abdul Kalam. When he visited to my institute in year 2012, he said that research teaches, research leads to good teaching and good teaching leads to research. Okay, so therefore, the good teacher should do the research and the good research leads to the good teaching there. So therefore, I went for the PhD and it's a lot of work I'm doing at the back end, but to do in the specific area. So when APJ Abdul Kalam addressed this, so then I decided to register myself for the PhD with the Ramji Prasad and these gurus mentors with me, and they have laid certain areas and you can do in the certain areas the research. Then I have gone through the literature I have done in the future radio access technology. Okay, you know that the another person Shiv Khera, you can win. So he has created the positivity. So I can do that. And the last person, you know that she Sindhutai Sarkar. Okay. So she visited in the year 2019 to our institute to just to help to their organization. We have organized the function and almost 5 lakh rupees we have raised and helped to the organization led by Sindhutai Sarkar. So this is the last statement to all my student friends. काहीही करा पण गुणवत्तापूर्ण करा. ज्या क्षेत्रात तुम्ही जाल त्यात जीव होता त्याच सर्वोच्च स्थानी पोहोचाल. Swami Vivekananda says, arise, awake and not stop until you reaches to your goal. मराठी मध्ये उठा, जागे व्हा आणि ध्येय प्राप्त होईपर्यंत थांबू नका. Thank you very much. If you have any question, you can ask. If any questions are there, you can ask.
I request all the participants that if you have any question in your mind, you please go ahead with it, because the sir will answer that question. If you have a barrier of language, you can ask in Marathi.
Marathi, no problem, no problem.
कुणाला जर काही प्रश्न असतील या संदर्भात, काही टेक्नॉलॉजीच्या संदर्भात, तर ते आता विचारू शकतात सरांना.
ही जी टेक्नॉलॉजी आहे तुम्ही वापरताय, माझं म्हणणं आहे की यू कॅन बिल्ड अ स्मॉल ऍप्लिकेशन ॲज अ प्रोजेक्ट बाय युझिंग द ब्लूटूथ टेक्नॉलॉजी, RFID टेक्नॉलॉजी, okay, infrared, okay, that is possible for all of you.
Yeah, yes.
Right. So as you are the BSc students, I have selected very simple topic to all of you so that you can able to understand that technology. Ultimate aim is so you can work in this area and build a small applications by using this technology.
Sir, my question is whether we are ready for 5G or not. India
Yes.
is ready for 5G.
Yes, we are ready there, but we have to update in the all the sense there. So
As far as infrastructure and other
yeah, that's
installations are concerned.
the infrastructure. First of all, we have to build for the base station, and that is it. It's going on there. Some standardizations are there because we have to think about, because when we are going to the 5G, so we have to see about the backward compatibility, because now there are a lot of subscribers are there. They are using the 4G.
Yeah.
And if I am coming into the market with the gadget which is the 5G enabled, and if it is not working for the 4G, So no people will take it that 5G technology because they have already with them the 4G. See how much money you have to see. Our country is very poor, and see, and in the day by day, based on the technology, if you are changing the see now, I will tell you what it is going to happen. So in the future, you need not to pay for the technology. You have to pay for the service.
Services.
So
Yes.
maybe they will provide themselves. Take it this my 5G mobile phone. Whatever you are utilizing the data, how much voice you are communicating. So utilization time period, just you have to pay it. So you need not to pay for the gadget nowadays.
Yeah.
So it will happen. It will happen.
Sir, what changes are going to be there in 5G? As
So
far as 4G is concerned.
yeah, 4G in the 5G, one is so all the applications are inbuilt into the 5G. So maybe you can have the video conferencing, high data rate. Maybe we can connect wireless to the any gadgets also. So that is the one area that is called as the convergency. So that is anywhere, anytime. See, whatever the technology which I have told you, that is in the ISM band. So therefore, those are compatible wherever you are going there. So that is your device, it is going to be connected to anywhere. Maybe if you are using by the Bluetooth there. Because worldwide, so that is having the same frequency of 2.4 gigahertz there.
Yeah.
Right. So here in the 5G, so you need not to configure the devices there. You have to access the devices through your mobile, and you can able to transfer the data to any devices. So the convergence is the main role, so which will play in the 5G.
What will be the data rate in 5G?
Data rate is very high. At least minimum it is 1 gigabits per second. Minimum.
Still, we are getting only 100 Mbps.
Yeah. So that's why I'm speaking, Nana. As
It
far
will
as
be almost 10 times.
10 times. Yeah. It's a minimum. I'm saying.
Yeah.
It's a minimum. So within a flash, everything it is going to be on your screen. You can, without streaming, you can able to see the pictures there.
Yes.
Without see now.
Buffering will not be the problem.
Buffering is not going to be there. See, if you are going to talk with the USA client, so when you are going to listen, so there is the delay of 1 second. It's observed there.
Yes.
But that is not going to be there in the 5G technology.
It will be in microseconds.
Yeah, very true.
Okay. Anybody having any other question related to wireless technology? Godke sir?
No. Good. Sir, you have cleared all doubts. No problem.
Okay. Thank you very much, sir. I have tried my level best because the question in front of me, because the audience of it is there.
Yes.
But I tried to simplify it, and definitely my ultimate aim was to make aware them about the wireless technologies and the wireless communication. These are the technologies which we are using. How you can able to build certain applications by using these technologies.
Yes. It was very nice and exhaustive talk on the wireless technology. And the subject is also very big. I cannot expect many things in 1.5 hours.
Yeah, that's true.
So we have to put some limits on that, and that's why we cannot go beyond that limits also. That's the problem.
Yes.
Of course, the explanation and other things was very nice, and it was in a very simple way, simple manner. We could understand. Even all the basic students of BSc Electronics, they can understand this technology. So I really thank Dr. Shirwal sir for making us aware of what will be the future of the wireless technology and how we are going to, or whether we are ready to accept that technology, 5G or whatever new technology they are going to emerge in the world. So I think he has cleared many of our doubts. Okay, and wireless will be the future of this electronics technology.
Yeah, it's very true. So definitely I will talk if time permits somewhere the other time. So
Yes.
So advancement and what is going to be the roadmap of this wireless.
Yes. Highly welcome.
If I'm going to talk now, so it is very hard.
Yes. The subject is very exhaustive and you cannot compress it in 1.5 hours. That's the problem.
ultimate aim was whatever the technology which you are
Yes,
using,
yes, yes.
so try to understand it, because you are using now the Bluetooth,
Yes.
Wi-Fi, RFID, infrared.
Yes,
Okay.
yes. Just
You-
we have
you-
surfed over
Yes.
the wireless technology.
Yes.
Okay. So I really thank Dr. Shirwar for giving us the opportunity for his attending his lecture and making us aware of the wireless technology.
So
I'm really,
it's my pleasure, sir.
And I
It's
would-
my pleasure.
yes,
It's
yes,
my
and
pleasure.
Yes, I would really request you that in future also you please be connected with us.
Very
And,
sure. Very sure.
Whatever problems we may face, that we may ask you.
No problem. No, always I'm going to help you in that
Yes.
regard. Right.
Okay, sir. Thank you.
And
Thank you very much.
I am also very much thankful to you, sir, for giving me an opportunity to interact with your students.
Yes, yes, sir.
So
No, it's
Deshmukh
our
sir-
honor that you have come, you have accepted our invitation.
And Godke sir also
Yes,
convey my thanks to your principal,
yes. Okay,
Dr.
sir.
Dr.
Sure.
B.D. Revadkar, and your science coordinator also, the
Yes, yes.
Lopande sir.
Yeah.
Okay, and your DBT coordinator. What is DBT means? Could not able to understand.
Department of Biotechnology.
Okay, okay, okay.
It's related to DST, Department
hope-
of Science and Technology.
Yes, yes, yes. I hope that is what is DST. I know that. What is this
Yes.
DBT? Okay.
Yes, yes. We have received that grant.
Through DBT.
Through DPT.
Okay.
So we have got the Star College status.
Right. RTS,
Only 100
congratulations, sir. RTS,
Yes, thank you
congratulations.
very much, sir. And only 100 colleges in India, they have received this status.
Very good. Very
And Shivaji College is one of them.
good. Excellent, sir.
So I request Dr. Godke, sir, to please give the vote of thanks.
Okay. Okay. Good afternoon to all. Respected President of today's first guest lecture on wireless technology, Dr. Bharti Revadkar, Principal of Sri Shivaji Mahavidyalaya, Barsi. Respected research person of today's guest lecture, Dr. Vijay Kumar Sirwar from NK Orchid College of Engineering and Technology, Solapur. My colleague, Dr. KP Deshmukh sir, who is the Electronics Department DBT coordinator for this guest lecture series 21-22. My colleague, Khardekar sir, teachers, participants, and students. It is really great that today's first lecture on wireless technology turned out to be very, very successful because total participants are near about 45. I am here to present the vote of thanks to the participants who made this event successful. First of all, I would like to thank the president of this guest lecture series, Professor Dr. Bharti Revadkar, principal of our college, for encouragement, support, and taking efforts to make this event successful. I would like to thank to today's speaker, Dr. Vijay Kumar Sirwar, for giving valuable, informative, and very, very nice talk. Very, very nice guest lecture on wireless technology. Participants understand the basic concepts of wireless technology. I also thank to organizing committee members, Dr. V.M. Gurme sir, Dr. T.N. Lokhande sir, science coordinator of this college. I also thank to my colleague Kiran Kumar Khardekar sir and participants, students, teachers for making this event successful. I am thankful to Dr. KP Deshmukh sir has given welcome speech of first guest lecture on wireless technology. I also thank again to Dr. Vijay Kumar Sirwar sir giving very nice guest lecture on wireless technology. Thank you all.
Okay, sir. With the permission of the chairman of today's session, the principal of the college, Dr. Bharti Revadkar, I would like to end this lecture. Shirwar sir, Shall we?
Yes, yes, sir. Yes.
Okay, sir. With your
Yeah.
kind permission, I am just ending up this.
Okay, thank you, sir. Thank you. Thank you
Thank
to
you
all.
again. Thank you all the participants.